So I gave students 2 minutes to complete the multiplication on page 11. There's not really much to say in terms of general announcements. The only thing I want to continue to highlight is that there are 2 different sets of homeworks within this unit that will be collected on a Monday. So all of the homework this week is going to be collected on Monday, the next time I see students, and all the homework on the week prior to the test will be collected on the day of the test, which is Monday, May 12th. Okay. We do have a CFU coming up next Friday. Next week will be nothing new. It'll just be a couple days of practice, and then Friday you'll come in, we'll do a little bit of review and take the CFU. Okay. Once again, the students are already given time to complete this multiplication, so we're going to move right to the problems at the bottom of page 11. These problems represent an opportunity to practice what we've already done this week. Okay. So first one says completely factor each of the following, show your work using the indicated method. And this is exactly what your CFU is going to look like next week on Friday. It's going to be 4 problems where you have to factor all 4, and all 4 have in parentheses the method I want to see you use. Okay. So the first one says factor by grouping. If you recall, basically this means look at the first 2 terms as one group, look at the last 2 terms as a separate group. So do that first. That's where the factor by grouping term comes from. Now, within each group, you want to figure out the greatest common factor. For example, in the first group, I can pull out a 2 because they're both even, and I can pull out an x squared because one has x to the third, the other one has x squared. But my job is to figure out what's left. And to figure out what's left when I do that, I have to consider dividing each term by that greatest common factor. Okay, so 6x cubed divided by 2x squared is 3x. And 4x squared divided by 2x squared is 2. Yes, sir. So the 2, I'm assuming you're talking about this one. That came from identifying what is the biggest number that can divide both of those numbers. Okay, so the greatest common factor. Now I have to do the same thing with the other group. This is factor by grouping. So we've factored one group, we need to factor the other group. Now the numbers 9 and 6 are both divisible by 3. But what I've said before is I don't like that the leading number is negative. So I'm not going to just divide them by 3. I'm going to divide them by -3. And then I'll figure out what's left. So I'm going to divide this term by -3. I'm going to divide this term by -3. So I'm pulling out a -3, and then I'm going to see what's left. Now, -9x divided by -3 is 3x, and -6 divided by -3 is +2. And this is where you get that nice green flashing light that says, yes, keep going. This parenthesis matches this parenthesis. That is what screams you're on the right track. Keep going. Because now I can pull a 3x plus 2 from each term. Okay? Now, if I take that away from each term, I need to figure out what's left. And the way I do that, I'm going to write this in green because I really don't think you all need to write this on your paper. But if you divide this term by 3x plus 2, and you divide this term by 3x plus 2, okay, well, the 3x plus 2 is, 3x plus 2 divided by 3x plus 2 is just 1. So you basically have 1 times 2x squared, which is 2x squared, and then you have 1 times -3, which is just -3. So what's left is 2x squared minus 3, and that's the term that's going to go in the other set of parentheses. 2x squared minus 3 is your final answer. That is the factored form of the original problem that was given to you. Okay? All right, we're going to look at one more of these. And by the way, to help us differentiate between the different methods, I told you all before that the thing that should tell you to use the factor by grouping method is that you have 4 terms. Okay, right here you've got 1, 2, 3, 4 terms. And if you have 4 terms, that means you should probably be doing factor by grouping. Okay, so to factor this one, once again, let me get rid of those highlights first. I'm going to take the first 2 terms, 3x squared plus x, and the last 2 terms, -21x minus 7, and I'm forming 2 separate groups. Now, the first group, there's no number that divides both of them. In fact, we only have one x, but they both have an x. So I absolutely can divide each of these by x. Okay, so I'm going to take away an x from both terms, and then I'm going to figure out what's left. 3x squared divided by x is 3x, and x divided by x is 1. Now, with the other two terms, both 21 and 7 are divisible by 7. Again, I don't like that the first term is negative, so I'm not going to divide just by 7. I'm going to divide by -7. Now, if I pull a -7 out of both terms, I have to figure out what's left. And that's why we do the division. -21x divided by -7 is 3x, and -7 divided by -7 is +1. And again, I'm happy to see that I've got two sets of parentheses that perfectly match. That is what tells me I'm doing this correctly. Because now I can take away a 3x plus 1 from both terms. Now, if I take away a 3x plus 1 from each term, I need to figure out what's left, which I would say you can see visually. I mean, these divide to be 1, so all you're left with is x. These divide to be -7, so all you're left with is those divide to be 1, so all you're left with is -7. So you have x minus 7. This is the final factored form. Now, those two problems are basically a summary of the method we learned yesterday, factor by grouping. Okay, now the other two methods, they kind of more so focus on what we learned on Tuesday and Wednesday. Okay, difference of squares being what we talked about Wednesday. And I said before, my opinion is the difference of squares method seems to be the one that kids like the most because it's so fast. Remember, what should really make you think difference of squares is you only have two terms. Okay? The other kind of giveaway is that you can take the square root of both terms. Like the square root of 4x squared is just 2x, and the square root of 9 is just 3. Like those are nice, clean numbers, which is what should make us think difference of squares. So all you have to do is use these two values and use those to write a pair of conjugates. Okay, so that's 2x plus 3 and 2x minus 3. That would be my final answer. All right, now the last problem, it's going to combine two methods. It's going to combine the GCF method and the difference of squares method. So this GCF we talked about on Tuesday, difference of squares we talked about on Wednesday. Now, when I look at this problem, I see two terms separated by a minus sign, so that immediately makes me think difference of squares. Like if I wasn't told which method to use, I would think difference of squares. The problem is you can't take the square root of 6. It's an ugly decimal. And you can't take the square root of 24. It's an ugly decimal. But if you notice that both of those numbers are divisible by 6, which goes back to your multiplication table, folks. There's a reason why I'm having you practice your multiplication table every day for the first 2 minutes. If you know your multiplication table, you're going to have a much easier time noticing that you can divide both terms by 6. So I'm going to pull a 6 out, and I do the division to figure out what's left. 6x squared divided by 6 is x squared, and -24 divided by 6 is -4. Now, this is the GCF part, but I'm still not done. I also need to factor this using the difference of squares. Luckily, that's pretty straightforward because now I can take the square root of both parts. I can take the square root of x squared, which is x, and I can take the square root of 4, which is 2. And then I'm just going to use those two numbers to write a pair of conjugates. But please don't forget about the 6 that you pulled out in the beginning. Like that should not magically disappear. I still have the 6. That was the greatest common factor. But then I'm factoring x squared minus 4 by writing it as x plus 2 and x minus 2. That is my final answer. Questions? All right, so the new topic with factoring is using the product sum method, aka the splitting the middle term method. I don't care which one you want to call it. You want to call it the product sum method, you want to call it splitting the middle term method, that's fine. I think it'll make sense to you after we do some problems today, why both of those names make sense. Okay? Now, please remember that factoring polynomials is the opposite of multiplying polynomials. The whole idea when you're factoring is to try to figure out, okay, I've got this giant polynomial. I want to know what smaller polynomials can be multiplied together to get that bigger one. That's what factoring is. Now, the three methods we've already discussed, you can just write GCF if you want. GCF is good enough for me. Greatest common factor, GCF. That was the first method we learned. Then we learned the difference of squares method. And yesterday we learned the grouping method. Alana, you good? Okay. Now, today we're going to discuss how to factor using what's called the product sum method. Now, I want to say a similar thing that I said yesterday at this point. I am about to summarize a process for you that I haven't taught you yet and we've never done before. So please don't think that the fill in the blanks we're about to do are going to make total sense. What I would recommend you do is copy them down as I give them to you, but come back to this part of your notes at the end of the period. Reread this statement, and I think it'll make a lot more sense because at that point, you will have seen it a couple times. So to get started, we first find the product of the first and last numbers. This is step one. Take the product of the first and last numbers. Then we look for a pair of numbers whose product equals that same product. Okay. Now the problem is, and again, this isn't going to make sense yet because you haven't seen it, but when you do this, there are a lot of different numbers that will multiply together to get you that same product. So you're going to have a lot of options. So here's how you narrow it down. But also, that same pair of numbers must sum to the middle term. This is why it's called the product sum method. You take the product of the first and last numbers, and then you say to yourself, I need a pair of numbers that multiplies to that, has a product equal to that, but they also need to add up to that middle number. That's the sum. This is why it's called the product sum method. Finally, we split the middle term using that pair of numbers and factor by grouping. Okay. This is actually why some people like to call this the splitting the middle term method. Again, I don't expect this to make sense. You haven't seen an example yet. Okay, so let's actually do one. Okay, our goal is to factor 4x squared plus 13x plus 3. Now, before we get to the fill in the blanks, let me walk you through a little bit of a thought process here. When I see 4x squared plus 13x plus 3, I know right away I can't use the greatest common factor method. I can't use the first method we learned because the first term has x squared, the second term has x, but the third term has no x's. So I can't divide everything by x. But the other thing is you've got a 4, a 13, and a 3. There is no number that divides 4 and 13 and 3. So there literally is no greatest common factor. So I can't use that method. The other issue is this polynomial has more than 2 terms. So I can't use the difference of squares method. The difference of squares method requires 2 terms. We have more than 2, so we can't use the difference of squares method. But we also can't use the grouping method because I told you all before the grouping method requires 4 terms, and we only have 3. Okay? So here's basically, here's the easiest way I can think to summarize what our goal is. We want to break that up. We want to break it into 2 separate terms. There are tons of ways. There are an infinite number of ways to break that up. You could break up 13x as 1x plus 12x, or 2x plus 11x, or 3x plus 10x, or 4x plus 9x. Everybody with me? Okay, but you could also break it up in other ridiculous ways. You could break up 13x as negative 100x plus 113x. Or you could break it up as 100x plus negative 87x. Like, there's an infinite number of ways to break it up. But here's the trick. There's one specific way that if you break it up in that specific way, you can turn this into something that you can factor by grouping. So we have a little bit of a trick. Mathematicians invented a trick to figure out the specific way you want to break it up. And here's how you do it. The product of the first and last numbers is, the first number is 4 because you have 4x squared. The last number is 3. And 4 times 3 is 12. So we need a pair of numbers whose product is 12, which is a lot of different numbers. You got 1 times 12, 2 times 6, 3 times 4. You've got a lot of different options. But here's the key. you also need the pair to add up to 13. So I'm curious if you all can help me out with that. Can anyone think of two numbers that multiply to 12 but add up to 13? 12 and 1, exactly. Okay. The pair of numbers, well, I put them in numerical order, but that doesn't actually matter. The pair of numbers is 1 and 12. So our goal is going to be, we're going to split 13x, the middle term. We're going to split it into 1x plus 12x, or as Sam said, 12 and 1. I don't actually care what order you put it in. It can be x plus 12x or 12x plus x. That makes no difference. Now, it turns out if you do that, if you split the 13x into 1x and 12x, like you basically rewrite the same problem, but you break it up into 4 terms, now you've turned it into something you can factor by grouping. So this one step, just figuring out what's the magic way to break it up, that's the extra step in the product sum method. But once you do it, you're right back to the factor by grouping method. Okay, so let me undo the last thing I put on the board. Let me pretend I don't know that yet. So I'm going to pretend I don't know that's the right way to break it up. And I'm going to kind of do this problem from the beginning. If I want to factor 4x squared plus 13x plus 3 using the product sum method, I'm going to multiply the first and last numbers, 4 times 3. Now, I need another pair of numbers that multiplies to 12. The problem is there are a lot of numbers that multiply to 12. There's 1 times 12, there's 2 times 6, there's 3 times 4, and don't forget, those could be the negative pairs. You could have -1 times -12, -2 times -6, -3 times -4. There's tons of pairs of numbers that multiply to 12. But the way I know which one I want is I look at the middle term and I say to myself, I want the pair that adds to 13. And the pair that does that is the very first pair, the 1 and the 12. So now I know if I take that 13x that's in the middle and I break it in this very specific way, 1x and 12x, then I am going to turn this into something that I can factor by grouping. Okay, so now I'm back to what we learned yesterday, the factor by grouping method. Okay, so the first pair is 4x squared plus x. The second pair is 12x plus 3. Now, all I have to ask myself is, what is the common factor? In the first group, I can divide them both by x. In the second group, I can divide them both by 3. Okay? That's the greatest common factor for each of those groups. Now, with the first group, if you pull out an x, you have to figure out what's left. So 4x squared divided by x is 4x, and x divided by x is 1. In the second group, if you're going to pull out a positive 3, so plus 3, you again need to figure out what's left. Well, 12x divided by 3 is 4x, and 3 divided by 3 is 1. And again, I'm really happy to see that bright flashing light that tells me what I'm doing is correct. 4x plus 1 and 4x plus 1. The fact that those parentheses match tell me I am doing this correctly. Okay? Try to be a little quieter with that. Okay? Thank you, sir. So we've got 4x plus 1, but I need to figure out if I pull out a 4x plus 1 from each term, what is going to be left? So I'm going to divide 4x plus 1. I'm going to divide 4x plus 1. And notice I am writing that in green because I don't really expect you all to show that work. I would hope you can kind of just see it in your own head. When the 4x plus 1s divide to equal 1, all you're left with is x. Okay? When these 4x plus 1s divide to equal 1, all you're left with is 3. So the remaining parts are x plus 3. And this is your final factored form. Now, I know that was kind of a long process, especially the first time you ever see it, but please remember, one of the beautiful things about math is you have the ability to check your own work. I'm going to switch to green. You don't have to copy any of this. But if you want to know that what you did was correct, just distribute. 4x times x is 4x squared. 4x times 3 is 12x. 1 times x is 1x. 1 times 3 is 3. And if you combine the middle terms, 12x and x, you get 13x. And notice this thing here is exactly what we started with. So that is a way of knowing what you've done is correct. Okay? Again, you don't have to do that part. That's just sort of a, if you want to check your work and know that you've done it correctly. Questions? All right, then go ahead and turn the page. We got 3 more practice problems and then we're done. All right, I am going to go through these ones a little more quickly with a little less green work, just to kind of simplify what you need to write down. Okay, but let me know if I go too fast. So again, just thinking about my thought process, or sharing my thought process. 5x squared minus 11x plus 2. It has more than 2 terms, can't use difference of squares. It doesn't have 4 terms. I can't use factor by grouping. And there's no number that divides 5, 11, and 2, so I can't use greatest common factor. So this is what makes me think, all right, product sum method. I'm going to multiply the 5 and the 2. Now I need 2 numbers that multiply to 10. The problem is there's a lot of them. 1 times 10, 2 times 5, and they can be negative. Negative 1 times negative 10, negative 2 times negative 5. But when you look at the middle term, it's negative 11. So I need to pick the pair that adds up to negative 11. So you all help me out with this part. Which of those pairs, because they all multiply to 10, which of those pairs adds up to negative 11? Negative 1 and negative 10. So this is the magic pair that's going to allow us to break up that middle term in a very specific way that turns this into something we can factor by grouping. So I'm going to take that negative 11x and I'm going to break it up as negative 1x and negative 10x. Okay. I'm hoping you all will be okay with it if I don't rewrite the groups. Hopefully we can just understand, you know, our first group is the first 2 terms. Our second group is the next 2 terms. Are we okay with that? Okay. So with the first group, I can divide both of those terms by x. So I pull out an x, and what's left is 5x minus 1. Slow me down, because I warned you I was going to go a little bit fast, so slow me down if I go too fast. With the next group, I have 2 even numbers, so I can divide them by 2. I don't like that the first one is negative, so I'm going to divide by a negative 2, just so I can change that leading term to a positive value. When I pull out a negative 2, negative 10x divided by negative 2 is positive 5x, and 2 divided by negative 2 is negative 1. And I'm very happy to see that this set of parentheses and this set of parentheses match. That's really critical. So if I pull out a 5x minus 1 from each term, the first term is going to have an x left. The second term is going to have a minus 2 left. And that is my final answer. Notice I did go through that one a bit more quickly. All right, we're going to do 2 more practice problems. Questions on number 3? All right, jumping down to number 4. If I went too fast, you weren't able to copy, you got to speak up. If I see a blank paper, then I'm going too fast. You got to say something. Okay? So number 4 says 2x squared minus 11x plus 12. When you're going to use the product sum method, you need to take the first number, 2, the last number, 12, and multiply them. Now, I want a pair of numbers that also multiplies to 24. The problem is, and this is why I have you all practice your multiplication table every day, this is a very long list. You have 1 times 24, 2 times 12, 3 times 8, 4 times 6. And any one of those pairs can be negative. Negative 1 times negative 24, negative 2 times negative 12, negative 3 times negative 8, negative 4 times negative 6. You have a ton of pairs. So you have to decide, well, which of those am I going to use? And the way you make that decision is you look at the middle term. I want the pair that adds up to negative 11. So can anyone identify that for me? Which of those pairs, because all of those pairs multiply to 24, but which of those adds up to negative 11? I've heard you say negative 2 and negative 3 and negative 8. You got it. Negative 3 and negative 8. Exactly right. Those two numbers multiply to positive 24, but because they're both negative, they add up to negative 11. So that is the magic pair you want. If you take that middle term, that negative 11x, and you break it up as negative 3x and negative 8x, you have magically turned this into something you can factor by grouping. Now, remember, your first group is always the first two terms. So the 2x squared minus 3x. And your second group is always the second two terms, the negative 8x and the 12. Now, with the first two terms, there's no number that divides both 2 and 3, but they both have x's. So I can divide both by x. The biggest number that divides both 8 and 12 is 4, but the 8 is negative. So I'm not going to divide by 4. I'm going to divide by negative 4. Now, with the first two terms, if you pull out an x, what you're left with is 2x minus 3. Because 2x squared divided by x is 2x, and negative 3x divided by x is negative 3. With the other two terms, if you pull out a negative 4, well, negative 8x divided by negative 4 is positive 2x, and 12 divided by negative 4 is negative 3. And once again, I'm loving that I've got two sets of parentheses that perfectly match. 2x minus 3 and 2x minus 3. So I'm going to pull out 2x minus 3 from each term. The first term has an x left over. The second term has a negative 4 left over. That is my final answer. All right, and happily, we've only got one other problem left, and then I'll donate the rest of the time for you all to practice homework 76. I believe, yep, number 1 says factor both polynomials using the product sum method. The next one actually says you need to use the GCF method first, then use the product sum method. So that actually combines the very first thing we learned this week with the very last thing. All right, last problem of the day. Now, in this one, don't get confused by the x squared. You have 1x squared. So the first number is a 1, the last number is a 35. So I need numbers that multiply to 35. Luckily, that is a much shorter list. The only numbers are 1 times 35 and 5 times 7. Of course, they could also be negative. Negative 1 and negative 35, negative 5 and negative 7. But looking at the middle term, it's 12. So which of those pairs, I'm asking you all, adds up to 12? 5 and 7. You got it. Thank you, Tal. Not the now no, so you would only want to select this one if it was a negative 12. Got it. You got it. Because it says plus 12, exactly right. All right, so if we break up that 12x as 5x and 7x, that is the magic way to break this up that turns into something that we can factor by grouping. Alana, you good? We're on page 13, number 5, bottom of the page. All right, so once again, I'm going to focus on the first two terms and the last two terms. First two terms, I can divide both by x. Last two terms, I can divide both by 7. So with the first two terms, if you pull out an x, you're left with x plus 5. And not shockingly, with the next two terms, if you pull out a 7, you're also left with x plus 5, which is, again, what I want to see. So if I pull out an x plus 5 from each of these groups, the first group has an x left, the second group has a 7 left. And that is my final factored form. In truth, on your CFU and whatnot, on tests, all of this, technically, I guess I could have been coloring green, because that's not really work I would require you to show. Okay? For our notes, I wanted it filled in, so I put it in blue. But for a test, your paper is just going to, it's not necessarily going to have that. You can just show me the work. You're going to get full credit. Okay? And with that, we are done. So again, I would recommend, we've got about 8 minutes. I didn't quite get you 10, but I would say 8 minutes is definitely enough time to finish at least problem 1, maybe even more. Okay? But homework 76 is your homework based on tonight's class. Remember, everything assigned this week, 73, 74, 75, 76, due on Monday, the next time I see you. If you're watching the recording, thanks for watching. Have a good one.